Exercise 17 to 24. Use the indicated substitution to evaluate the integral. Confirm your answer by differentiation. So that in the book, they tell you what to use for u. But I removed that because I think, well, we're going to practice picking that out. Today we want to pick the function so that its derivative is in there also, but it's okay to have a multiple of its derivative, like 2 times its derivative, -7 times its derivative. That's okay. So what I see when I look at this is I see u equals 2x squared. I see a function, and I see its derivative there, but a multiple of its derivative. So the derivative of u with respect to x is 4x. But we like to multiply the dx over because we have x dx here. So we have du equals 4x dx. And I usually just multiply that over right away. And you'll see what I mean by that. Or if you've watched the video, you've already seen it. Well, now I can replace, well, I'm not quite done yet with this because I don't have 4x dx. I have x dx, so we're going to divide by 4. So 1/4 du equals x dx. Now I can replace. I have what I want. So this integral becomes the integral of x dx becomes 1/4 du. And I usually just pull any constants, any multiples out front. So x dx becomes 1/4 du. And now I have, instead of cosine of 2x squared, I got cosine of u. Cosine of u. And now we've turned it into something that we can take the antiderivative of. The antiderivative of cosine is sine. So we have 1/4 sine of u plus c. Well, I didn't start with u's, I can't end with u's. U is 2x squared. So it's sine of 2x squared plus c. Now we're done. Done with the problem, we got it done. But the question is the derivative of this that? Well, the derivative of sine is cosine. So I have cosine of 2x squared. Derivative of c is 0. I have the 1/4, and then we would take that times 4x, right? The derivative of the inside. And the 1/4 and the 4 would cancel out, and we'd be left with x. So that is, the derivative gets you back to what we started with. Questions on that process? Number 20. What should we let u equal? We want to take as much as we can, but not so much that the chain rule starts creating a mess. So what do you think we're going to let u equal on 20? 7x minus 2, right? We can't have 7x minus 2 to the third because then the derivative is too much of a mess. So 7x minus 2 du is equal to 7 dx. I don't have 7 dx, I have 28 dx, but that's okay because we can just multiply both sides of this times 4. Now that's 28 dx. So 28 dx becomes 4 du, 4 integral du, and now we have u to the third, u to the third. Now the question is, do we have something that we can take the integral of? Well, certainly. We add 1, I was thinking 4. Add 1, so 4 times 1/4 u to the 4th plus c. And the 4 just tags along. You can kind of ignore it, but you got to keep it with everybody. So this becomes 4 times, well, no, not 4 times. 4 and 1/4 cancel. So it ends up being 7x minus 2 to the 4th plus c. Now the 28 takes care of itself because now we're done. That's the answer. Multiply by 4, reduce that power by 1, and then multiply that times 7. That's where you get the 28 from. All right, a function and its derivative. I'll go quickly through 22. U is equal to 1 minus r to the third. I can't take the square root. I can't take that much because then the chain rule would get in the way and that derivative would get rather complicated. I just want the derivative to be a multiple of 9r squared. So du equals -3r squared dr. It's really du over dr is equal to that, but then you can split the differentials, so we just write it over there right away. Well, I don't have negative 3r squared, I have 9, so I need to multiply both sides times negative 3. That's where you get the 9r squared from. Well, now we have the integral, well, negative 3 times the integral, negative 3 du, and that's 1 over the square root of u. Now we have something we can take the antiderivative of. This is the same as negative 3 integral of u to the negative 1/2 du. And we're going to add 1 to the power. That's negative 3 times, we would have u now to the 1/2. Negative 1/2 plus 1 is a half. But if I took the derivative of this, I'd have 1/2 out in front. I don't have 1/2 out here. So we got to get rid of that 1/2 by including that 2, then plus c. So the answer is negative 6 square root of u, which is 1 minus r to the third plus c. Questions on that one? Go ahead.
So going back to where you switched from, it's like negative 3 integral of 1 over square root of u.
Where's that now?
It's like the third line.
Right here?
Yeah.
Okay.
How did you get a 1 instead of like the r squared?
How did I get a 1 here?
Yeah.
Instead of that? All right, so this right here, that's equal to 9r squared dr, right?
Yeah.
This right here. Well, we're saying this is equal to this.
Okay.
So I'm replacing this with negative 3 du. Whoops, I need a du there. Negative 3 du.
Oh, so you multiply it?
I'm replacing.
Okay.
It's a replacement. All right, over on the next one. What do we take the derivative of that looks close to this? Almost that. Inverse tangent, right? But for inverse tangent, we need 1 over x squared plus 1. We can't have the 16 there and say that's the derivative of inverse tangent. So we need to pick a u that would make this, when I replace, that would make that, if I could make that 16u squared, I could factor out the 16 in the denominator, and I'd have u squared plus 1. So we're going to make this something kind of strange. We're going to pick u to be x over 4. I get that from the square root of 16. Square root of 16 is 4. Now we're going to multiply this 4 over. I'm going to make 4u equal to x. And if you're real savvy, you just start with that. You just say, well, 4u is equal to x. Now why? Well, if I replace x with 4u, I get 16u squared. So now we have, but we got to take care of this also. So 4 du, the derivative of 4u is 4, equals the derivative of x is 1, so dx. So if I replace dx with 4 du, and I replace x with 4u, I get 1 over 16u squared plus 16. That was the whole goal. Get that to be 16 with both of them, and I can factor out the 16 out of the denominator. So this becomes 4 over 16 integral of 1 over u squared plus 1 du, and I have exactly what I want. Now I can make this 1/4 inverse tangent of u plus c. And so the final answer, the u is x over 4. We have 1/4 inverse tangent of x over 4 plus c. That's the answer right there. Questions on that one? Let's try it again. Or not. Dang computer. I don't know why it just decides not to work all of a sudden. So here's almost exactly the same thing. We're going to let u equal x over 5. So when we square this, we square the 5, it becomes 25. But we got to multiply the 5 over. We're going to say 5u is equal to x. If we replace x with 5u, both of those have a 25. but then we have to take care of the derivative part. Here's the calculus part. So 5 du is equal to dx. I can replace dx with 5 du, so we have 5 integral du. And then I can replace x with 5u, making that 25u squared. So 1 over 25u squared plus 25. We can factor out the 25 out of the denominator. That makes that 1/5, 5 over 25. Integral of 1 over u squared plus 1 du. And we have what we want. We have the derivative of inverse tangent. So the answer is 1/5 inverse tangent of u, which is x over 5. That's right there. And then plus c. So if that number was 49, it'd be u over 7. Go ahead.
Am I dumb, or when you pulled the 5 out of the denominator, would it not go to like 5 over
5 over 25. We're factoring out 25.
5?
Pardon the interruption. 10th graders with the last name beginning A through R, please come to the auxiliary gym for the health screening now. 10th grade last name beginning A through R, please come to the auxiliary gym now for health screening. Thank you.
On number 26, I don't think we really need substitution to do this one, because if we pick this to be x plus, if we pick u to be x plus 2, the derivative is 1. When the derivative is 1, I don't think we need u substitution. This is tangent of x plus 2 plus c. Because the chain rule doesn't really mess it up. We're just multiplying by 1. So I picked one where we could use the substitution process, but I don't think we need to. Anyway, number 1 through 6 in your homework is just like that. They're not asking you to use substitution, they're just asking you to take the integral. All right, number 32, what should we let u equal? Do we see a function and its derivative in this? I do. What should we let u equal? Cotangent, right? Cotangent of x. Not square root, because then the derivative gets too messy. So we're going to let u equal cotangent of x. Du is equal to negative cosecant squared of x dx. We don't have the negative, so we'll bring the negative over to the other side. We'll just include that in the substitution. See, negative multiples of our derivative, that's fine. We can just get it to the other side. All right, so now we have negative integral square root of u du. Cosecant of x dx, that became negative du. Then we have square root of u. Well, this is the same as negative integral of u to the 1/2 du. We're going to add 1 to the power. That's negative u to the 3/2, but times 2/3 plus c. We didn't start with u, we can't end with u, so it's negative 2/3. U is cotangent. Square root of cotangent to the 3rd x plus c. The bottom is the root, the top is the power. So the power is 3. Good stuff. Man, I love this section. It's beautiful. It's like a work of art. What's 34? What are we going to let u equal? We got tangent to the 7th of x over 2 and secant squared of x over 2. What should we let u equal? As much as we can, but not too much. Go ahead. Tangent of x over 2. You're like, really? You can just pull that tangent out? Well, sure. Tangent of x over 2. So then du is equal to 1/2 secant squared of x over 2. So the derivative of tangent is secant squared, derivative of the inside is 1/2. Now that 1/2 is okay, because we just multiply both sides by 2, so we have 2 du equals secant squared x over 2 dx. So that gets replaced. That's your derivative right there. Your function is tangent. Now, we couldn't take tangent to the 7th because then the derivative would start getting the chain rule involved, and then the derivative would be much more than just secant squared. Uh-oh, it's going to crash now. That's where I'll just bring it back up. Integral of, let's see, we'll see how far we can get with this. U to the 7th du, I think I'm almost done actually. I have 2 du, oh, I already got the du. The secant squared x over 2 is du, 2 du, and then we have u to the 7th. I add 1, so I have 2 times 1/8 u to the 8th plus c. Now I just replace the u. So that's 1/4 tangent to the 8th of x over 2 plus c is the final answer on that one. Yeah.
Where did the 2du, like how did that, like why did equal 2du equal secant squared?
All right, so let's back up to where we let u equal this, right here. The derivative of that is secant squared of x over 2, and then the derivative of x over 2 is a half. You with me so far?
Yeah.
Well, I have the secant squared x over 2 dx right here, but I don't have the half with it. So we're just going to multiply that to the other side. So that when I replace secant squared x over 2 dx, I replace it with 2 du. So 2 du comes from replacing that.
Okay.
Did you follow that?
Yeah. A little bit more.
Kind of? Okay, go ahead.
Where did you pull the U from the 7 out of? Like it just kind of,
Where did I do what? Say that again?
because you see where you have the 2 underlined and the 2
Oh, yeah.
underlined?
So u to the 7th, where did u to the 7th come from?
Yeah.
Okay, so u is tangent of x over 2. So this right here is u to the 7th. So if I had it like this, if I had tangent of x over 2 to the 7th, right, like that, and I just let u equal tangent of x over 2, just the inside, well, doesn't that become u to the 7th? Like that? That's where it comes from. Anything else? Go ahead.
How do you know not to start with like secant or
Okay, so
the opposite one?
I like that question. How do I know? So what do you want me to pick?
Well, I just mean in general, like
Yeah, yeah.
how do you know
No,
what
no.
to pick for you?
Pick something. Like something other than what we picked. Like secant?
Yeah.
Okay. So we let u equal secant of x over 2. Then the derivative is secant of x over 2 tangent of x over 2 times 1/2 dx, right? That's the derivative. Well, I don't see a secant tangent here. When I let u equal, like if I let, now we're gonna let, this becomes u squared if we let u equal sequent, but then I have this tangent to the 7th. How am I gonna replace tangent to the 7th when I let u equal sequent and this secant, and this is the du? Like, how am I gonna get a tangent to the 7th out of that? That would be the problem. Now, what I do see when I look at this is I see a function and its derivative. I see a function that is tangent, and I see a derivative of that tangent being secant squared. So that's what I'm going to play around with. That's why we don't pick secant. I don't see the derivative of secant there. Not really. Good questions.
It's like on 32.
Okay, let's go back to 32. What do you got?
So you picked cotangent because it's the derivative of cosecant?
I picked cotangent because the derivative of cotangent is negative cosecant. And
Okay.
the negative doesn't mess anything up. That's not going to be a problem.
Okay.
Okay, so we're looking for a function and its derivative. And so we can go all the way back to anything you want. This is a little weird though. That's a little wonky. I'm biting. I know this is going to crash. I know it's going to crash. If we go back to the beginning, I saw a function and the derivative of that function being x. Derivative of 2x squared is actually 4x, but that's okay. Here I saw 7x minus 2, and the derivative of 7x minus 2 is 7, but the variable's gone, so it's a version of its derivative. Here we see 1 minus r to the third. The derivative of r to the third is 3r squared. So it's very similar. Anyway, you're looking for a function and its derivative. Let's go back to this and let's see if we can finish the tangent one before this all crashes down. I can't, the extend page is gone, so I'm going to erase this. Are we good? Everybody good? I'm gonna erase this so I have room off, maybe. Okay, maybe I'm not gonna erase it. Whoa. All right, well. All right, it's erasing everything, lines, everything. There we go. All right, tangent of x. There's not a whole lot to work with, right? It's just tangent of x. Derivative of tangent is secant squared. There's no secant squared there at all. So if we're looking for the integral of tangent, there's just not enough. So we're going to make this sine of x over cosine of x dx. Now, we have a choice here. Unfortunately, we have a choice because they're the derivatives of each other, with the exception of the negative, of course. So should we let u equal sine or u equal cosine? Sine. So du is equal to cosine of x dx. Do I have cosine of x in this function? Are you sure? You say no. Why do you say no?
You have 1 over cosine.
We have 1 over cosine in this function. We don't have cosine in this function. If we have cosine, it has to be on top. Not 1 over cosine. That's secant. We have sine and secant in here. We don't have just cosine. And I would have said yes too. Before I did this problem, when I taught this for the first time, the day before I taught it, when I was looking at how to do it, and you said, do I have cosine in this function? I would say, yes, you sure do. I would have said the same thing, but it's not. There's not a cosine in this. That looks like it should be it. It looks like you should pick sine to be u, but you actually pick the denominator. We can substitute anything we want for u. So we're going to let u equal cosine of x. Du is equal to negative sine of x dx. We have sine in this. All right, so I can put u in for anything. Now we have negative, because I got to get the negative over the other side. Negative integral of 1 over u du. Because cosine becomes the u, and sine of x dx becomes negative du. So this is negative natural log of the absolute value of u plus c. And then we just have to replace the u. So negative natural log of absolute value of cosine plus c. Now, why? That's the answer, first of all. We got the answer. Now, why does that work? Well, look how we're going to get cosine in the denominator. The derivative of natural log is 1 over x. So it's 1 over cosine of x. That's the derivative of natural log. Then the derivative of the inside is negative sine. But a negative times a negative makes a positive. So then we have sine of x on top. So you need to pick u to be the denominator. So now if we do the integral of cotangent, you got to make u sine. You have to make u the denominator on this. All right, man, love this stuff, but it wears me out. Here's the tricky one, because we don't do a ton of these. So every time we come across it, it's like I have to reteach it all over again. So the better you can grasp it right now, right away, the better off you're going to be. That's the name of the game in Calculus BC. How quickly can you get the grasp of this stuff? Because we're moving. This class moves quickly. All right, anyway, questions on this? Your assignment is a 2-dayer. I'm going to throw some AP questions at you tomorrow. But 1 through 11 odd, 17 through 39 odd. Oh, to get it on the video, I should probably bring it up. That would probably be nice. Not 51, 63 to 65, 71 to 76. It's a long assignment, but it's meant to be done over the next couple days, not tonight. So we'll just extend it a little more tomorrow. Yep.